Gracias por estar aquí, estudiantes, amigos, profesores del patio y disciplinas conjuntas que nos unen en el diseño que yo quiero ver de las disciplinas de arquitectura de otros aliadas. Les tengo que informar que el grado de diseño de producto va a estar corriendo a principios del año entrante en Ford como primera iniciativa de este grado que quería aliar disciplinas conjuntas en el programa de arquitectura. Así que todos los que estén interesados pueden empezar a buscar información sobre el asociado, estar a cargo de diseñador de Figueroa. Así que lo otro les cuento que desde muy temprana edad, cuando me dio la tarea de ser decano, pensé que este programa necesita diversificar y el enfoque de nuevas disciplinas de diseño dentro de la arquitectura. Así que eso es lo que estaba haciendo, dando relaciones con los esfuerzos, gente como Eddie que me ha ayudado, un equipo de profesor con el tema, David Figueroa que siguió. Así que hoy tenemos posiblemente un esfuerzo conjunto que nos une en esta situación de crear un buen país. Así que también tenemos una certificación de planificación urbana, así que vamos a diversificarlo. Más de eso es difícil hacerlo y se lo digo con mucha humildad porque nuestros cuerpos de normativa, de legislación y demás, no cambian al mismo tiempo. Eso puede decirse aquí, amigos míos, que en el programa de arte plástica. Así que, bueno, sin más, les dejo con él para que explique a nuestros conferenciantes y muchas gracias por estar aquí hoy.
Bueno, bienvenidos a todos. Como saben, es una serie de esfuerzos que se han estado desarrollando a partir de la creación del grado asociado de diseño de productos, que acabo de decir la noticia que comienza por en términos de su curso. Estos esfuerzos también han estado amarrados a una otra serie de iniciativas para el desarrollo de la recreación al aire libre, por la Asociación de la Industria de Puerto Rico. Y una de esas colaboraciones han dado fruto para que este día tengamos la oportunidad de tener a Andrew de la Universidad de Utah State University y es el director del programa de diseño de productos para outdoor recreation. Así que Andrew, lo introduzco un poco. Andrew tiene un doctorado en manufactura aditiva, tiene una maestría en ingeniería y tecnología en educación de business processing y un bachillerato en ingeniería de tecnología de manufactura. La idea de traer a Andrew no solamente es hablar del proceso de diseño, sino hablar de los procesos de manufactura para poder entender cuáles son las realidades del diseño y las posibilidades de que esos diseños puedan ser producidos en masa y distribuidos por sistemas de distribución serio. Así que la conferencia la vamos a hacer en inglés. Hay posibilidad de traducción para en caso de que alguien quiera hacer preguntas eventualmente al final de la conferencia. Creo que van a subir varias. Así que les voy a dar con Andrew. Please welcome.
Thank you. It was a pleasure to be here this evening. Hablo español poquito. Donde está el baño, Conferencia. So I'll try to enunciate very well. Hopefully that can help with some of the language. As they're saying, I'm here from the Utah State University program in outdoor product design and development. So it's still a relatively new program, about 4 years old. And so we just had our first graduating class. They're now out there working in the industry, having a lot of fun. Glad to be done with school. But we had a lot of fun projects along the way, a lot of great experiences that we'll kind of talk about today and talk about design and manufacturing as well with some of the innovative products they put together. So just to give you a little bit more background on myself. So I'm Andrew Deceuster. As Eddie said, got my doctorate in engineering. So I come with more of that engineering background, engineering design. Worked in the archery industry for about 6 to 7 years. Did a stint in the bike industry when I had a design center at another university. Worked in aerospace. So I have a great time. Love the outdoors. Utah is a great place. come experiencing those outdoors, lots of rock climbing, hiking, biking, climbing, skiing. It's great. But we do get a little too cold sometimes, so it is nice to come here and warm up, thaw out. It did snow on us on Wednesday last week, so we're happy to be here. So I have a great time. I've got 5 kids, so we run all over the mountains. They keep me busy. Yeah, it gets crazy from time to time. So we kind of jumping into it. We'll kind of talk about product designs, manufacturing, product usage, and also end-of-life management. So being in the outdoors is kind of a different industry than typical product, and so we'll really kind of get into that. So why design matters? You know, where do those products go? And this is where outdoor starts to really differentiate itself from typical consumer products. So fidget spinners, they were huge. Now they're not. Millions of them are ending up in the dump, in the landfills. They did a horrible job educating their consumer about how to dispose of it. Pretty much the entire thing's recyclable, but everyone throws them in the garbage. No education. So as a designer, what can we do with that? How can we make a difference there? And so I wanted to kind of lead into how do we approach outdoor design. And so I've got a great little video here from some of my from a student, Nate Larson, who put this together. I'll jump on it real quick. So I just want to show that to you real quick, so you can get an idea of what we do.
Placing that in there,
Like the velvet red.
what the pack actually is.
Yeah. Put some orange. Ooh.
Okay, turn it. There. Kind of pretty cool, huh? Yeah?
One thing I really like about that video is it shows that whole process of design, going from concept, iteration, prototyping, and then the best part about the outdoor industry, testing. So you can see he's designing that bag for his little boy. He's able to then take him out there, test it, see how the gear actually works, holds up. And that's where it becomes such a fun industry to work in, is you actually have to get out there and use the product and have a great time with it. And so the idea is when we look at those outdoor products versus consumer products, you know, those outdoor ones, we go outside with them, and really the big thing about the outdoor industry is we're supposed to leave very minimal impact. So the idea is that we design these products to last, or we design them to have some kind of future once they've expired in whatever activity is that they're using. Whereas a lot of consumer products are designed to be disposable, we just throw them away. And we've kind of gotten into that mindset of a disposable generation where they just are used to disposing of everything you go buy new. And so the outdoor industry will really strive to be more sustainable and push for that. So that's where I kind of want to get into the difference is the outdoor product design and the industry. They all kind of center around one main idea, and that's sustainability. And that's where it differs from a lot of other design programs. So our design program, we really focus on sustainability, how to reuse materials, how to use the right materials. What are the ones that have the least amount of impact? What are the ones that are environmentally friendly? Which ones are ethical for animal treatment? Things like that. Because why does sustainability really matter? Because they become standards in the industry. And so these are standards that have been quickly adopted by the outdoor industry. And as time goes on, we're going to see more of these standards adopted by just the normal consumer industry. Because it's what's right for the planet. So REI, one of the major retailers for outdoor brands, basically came out and said, here's our standards. If you don't meet them, we don't sell your product. And so it quickly, and they were good to work with brands, but they quickly came out and said, well, here's what it's going to take. So we need our fair and safe trade. We need our product impact with the Higg Index. And the Higg Index is a great tool for helping you analyze your product and its sustainability. So it takes into account where it's being sourced from, what the material is being made out of, who made that material, how much is being utilized by the product, and it gives you a rating. And these are some of the things that traditional industrial design programs don't touch on. So that's one of the benefits of having it focused on the outdoors, is because it really takes into account the sustainability aspect of the product. And so it's a great tool to help you measure that. And so when you go to REI, you go to these outdoor brands, if that's something that you're interested in the future, become familiar with it. So that way you can see that impact. And then you can say, well, here's my impact. Now you got a nice benchmark. Once you benchmark yourself, then you can actually work your way and lower that impact score, picking other materials, picking this, picking that. Because what I found with a lot of students is they don't realize maybe the impact of cotton versus wool versus synthetics. The amount of water that it takes to make a pair of jeans is around 20,000 gallons, from watering the cotton to producing the dyes, all the water used along the way. Chemical management becomes a huge one. So what are the chemicals that go in? BWRs for waterproofing, things like that. Are they the safe kind? Are they the ones that have all the fluorochemicals in them that are toxic to the human body? Are they getting dumped in the rivers? Are they being properly disposed of? And so that also tails into your land stewardship and taking care of the land that we enjoy. So that's the catch with outdoor products, is you have to use your product in the outdoors. So if you destroy your outdoors, you got nowhere to use your product. And so that's the reason that the outdoor industry focuses so hard on trying to maintain that sustainable approach to developing their products that they use. And then animal welfare is a big one. So are they treating the animals right? We've got some pictures in here to show you what I mean. The down jackets, things like that. Are they live plugged? Are they ethically captured? And again, environmental management. All become major players in it, because we can look at some of the catastrophes that we see from materials that we need for our products. And so the Ariel Sea in Russia used to be a great, nice lake system. They had a huge need for cotton because they were designing everything from cotton. So they started diverting all the water. Well, there is no natural outlet from the Ariel Sea to the ocean. And so as soon as it started drying up, all the salt became encrusted on the surface, winds blew it over the farmland, it made the salinity content of the soil too high, no more cotton plants, completely destroyed it, destroyed the whole area, destroyed the ecosystem. Again, ethical sourcing, you can see a live plucked goose where they just rip it right from the animal, they don't humanely treat them. Plastic islands, where we see this in the oceans everywhere. Rainforest destruction. One of the islands in Indonesia completely clear-cut their entire rainforest planted palm trees because they wanted palm oil for biodiesel. Then biodiesel didn't quite work out, and they said, well, what do we got now? We got a lot of palm trees and no rainforest anymore. So they destroyed again, and then I don't know if there was much effect here from the BP oil spill off the Gulf, but oil spills we see all the time to get that synthetic material that we need. And so we just want to be super careful about how we harvest those raw elements and what we do to the environment along the way. And so as a designer, you make those choices because you're the one who chooses what those materials are. You're the one who chooses how much is being used. You're the one who kind of helps the team decide where to get it from. Is it going to all be organic? Is it going to be synthetic? Is it going to be reused, recycled? So that's where designers can play a key role in this. So when we kind of look at the outdoor industry, the way we like to approach it is now what we call the circular economy. So the whole idea is that we have our design, we jump into manufacture, and there's retail, users, repair, reuse, recycling. And so the idea is that maybe a raw good is introduced, but it should be able to cycle around. And that we should constantly try our best to reuse those materials as much as we can so it becomes circular. And we don't just have a one-time, comes in, goes out to landfill. That's the opposite of what we really want in the outdoors. And so the great thing about this is it becomes such an interdisciplinary approach to the industry because we've got designers within manufacturing, we've got a lot of engineers in here, we've got fashion merchandisers, product line managers, retail, sales, buyers that can play into this. Users, we've got a great tourist destination here, being a lot of the users that come into play. And then another great aspect here between recycling, reuse, and repair is more business opportunities, more entrepreneurism to set up companies. Because now I can take a product that was slated for the trash and I can convert it into something new. So I'm working with our students right now. We get a lot of offcuts from textile mills for the headers, and we're turning them into chalk bags. And then the students sell them as a fundraiser. And so it's fun because you never know what fabric's coming in. So it could be any kind of texture, any kind of pattern, ruffles, pink, fur, who knows. And so there's nothing like having a nice ruffly, furry chalk bag that you're taking up the side of the mountain. And it becomes a new product category. We've got everything from that to dog leashes, to new tents, to all those types of things. So it's a great approach because it brings in so many disciplines to work together on projects and help grow that sector. So again, the circular economy is kind of the standard that the outdoor industry is working to. And so you'll start to see a lot more industries coming along, following suit. Patagonia being a big one pushing for this. If you've seen their Warrenware Center where anything can get sent in, they'll prepare it, send it back, and push on. So being a great example there. So as we kind of jump into product design, it becomes a great one. Again, products always start with a problem and end in a solution. So how many people have smashed themselves in the face with their phone, fall asleep, drop it? Well, obviously we got the pop socket, right? Great solution to help hold your phone. Again, we want to do that research. We really want to figure out what is the problem, define that problem, give it that proper definition, ideate possible solutions. My solution is just get a giant hand like mine, you can hold phones really easy, and you can reach the whole screen. But since you can't grow your hand, pop socket works great. So prototype those concepts and then test them. Again, because when we don't test, we don't really know if we achieved what we were set out to do. So research, an idea is not just enough anymore. We used to have people just get an idea and they start running with it. So really what we want to do in our research, we want to understand the problem. We really want to empathize with the people. Understand what it is that problem, how that problem affects them, so we can make sure we address the correct problem. And then what are those impacts? Are there environmental impacts if we make that solution this way? We use this, we use that. So when I was doing some research in the archery industry, we were looking at doing a new coating on some of the components for release. And in the States, they was getting quoted about $2.50 per part to get this coating. We took it to China just to see what their pricing would look like. And he told me it was 15 cents. And I said, no way it could be 15 cents. Because in China you get your cost savings through labor savings. I said, this is a non-labor intensive process. It soaks in cyanide salts and all this. I'm like, how? How can it be that cheap? And they said, well, we don't have the EPA like you do. I said, oh, so the impact is you just dump this stuff in the river. And so we decided not to go that route because we didn't want that environmental impact on the head of the company. And so we really got to drive in that research and figure out what we're doing. So backpacks, again, kind of a great example. You know, is the backpack that you need for this situation the same as you need for just taking a stroll? What is it that you actually need? Do you need a 30-liter bag? Do you need a 60-liter bag? Do you need this many compartments? Do you need that? Who's using it? Oh, it's a woman using it? They have a different frame than a man. Maybe we should actually analyze a female back structure so we build a bag to fit them and not just fit the male counterpart, which has been so common in the industry in the past. And so the more research we can do and figure out the differences of users, differences of culture, we can start to find the right solution for that demographic of people that we're designing for. And that's really what it comes down to as a designer, is we need to find the answers to those problems and then come up with a proper solution. And so one of the other benefits to doing proper research is it helps us find those holes in the market. We can find those opportunities. So once we've identified a proper opportunity, it gives us that chance, if we've got that entrepreneurial spirit, to go ahead and start our own company, try something new, launch a new business, or expand the offerings of the company we're working for. It's those holes in the market that once you find, boom, you can find instant success overnight. But it's really just trying to lock in what is that opportunity and what does it look like. And so communication becomes really big in that research and defining the problem. So I like this graphic because it's, you know, how the customer defined it, how we understood it, how the analyst designed it, how the programmer wrote the code for it, how the business, how we described it to the customer, you know, how it was supported, how it was billed, and then again, the customer, all they really wanted was that tire swing. And so it becomes very important to, pops up. So sometimes you never know though. So my two little boys were playing in the park. They realized the swings would unconnect from each other, and they put the double-decker swing into life. They thought it was the greatest invention they had ever made until the first swing, when the one on the bottom realized that the one on the top kicked him in the face, flipped him off the back. So they look really happy right here when my wife snapped that picture. But again, the idea is it may look like a great product, and then you go and test it and realize that was not fun. That was not a good idea. And so that's one of the reasons that we as designers need to play with design and figure out what's going on. So defining that problem. So for myself, I'm about 6'4", 6'5". I'm about the shortest in my family. I've got 4 brothers. Me and the one that you see right here are about the same size, but my older and one of my younger brothers are 2 inches taller than I am. So one of the problems that we found, we were sitting around the table one night and said, wouldn't it be great if clothes fit tall, slender men? And because every shirt you buy, they always say, well, if you're tall, you must be big and tall. And so we said, well, hey, why don't we just design some shirts for tall, slender guys? So this is the problem that we defined, and then we said, well, hey, we can do it. So one of the benefits of this that a lot of people don't take into account is how much wasted fabric is there in a shirt like that. There's about 33% of the fabric is not utilized. It's just waste. It's the poncho fit that we get. And so by removing that and adding just a little bit more length to the overall thing of the shirt, we had shirts that fit correctly, use less materials, they were more sustainable in that approach to material utilization, and it was a better product, a better fit. And so the nice thing is, my younger brother runs the company and supports his family with it, but we found that niche opportunity, and now there's a business that supports a family. And so he can run that. And that's why, talking with some of the textile stuff here in Puerto Rico, it'd be great to have some of those conversations about maybe producing some designs here in Puerto Rico. But again, you find that hole, you find that opportunity, you design the right product to fill that need, and boom, there could be a business overnight, we said. So ideation becomes so crucial as a designer, as to playing with that design. So these are shoe designs from one of my students, Veronica Vilhart. So she loves shoes, and she loves sketching. And so she would sketch shoes all the time. And she would sit there and ideate and play with those shoes until she landed on kind of a design. And so these are some of her favorite designs. I had her take pictures for me. And so Black Diamond looked at it and said, "We want you as a shoe designer. We've got Under Armour looking at her saying, this would be great potential here, you know." So it's great to see the ideation that can go on, and the more you play, the more you start to land on your style, what you're looking for. And so it's just a great opportunity to take that time and really figure out how it should look, how it should function, those types of things. And so that's where it comes into the form, fit, and function of a product. So as a designer, we need to take these into account very critically. Because everyone likes form, right? It's got to look good. The fit doesn't make sense. Is it going to fit right? Does it match together? And this is where design and engineering really need to come in hand in hand to work with each other. And then functionality. Because the engineer is the one that's always pushing our functionality. The designer is always kind of pushing our form. And so as we understand both, we can kind of understand it better. But when you look at companies like Black Diamond, when they have a team come together to make some new climbing equipment, they bring together their industrial designers and they bring together their engineers. So on that team, they've all got somebody in there that can understand, well, hey, that needs to be stronger, that needs to be this material, that needs to be that material. And so by blending that discipline, which is kind of what we've done with our program, they understand those material strengths, they understand the materials, they understand how it should look, those types of things. And so to that end, when I was in the archery industry, I designed this mechanical release aid right here. It was a dual jaw, mechanically linked. Normally the jaws can open independently, so people didn't like them as much because they can shift side to side. But I mechanically linked mine so they would open simultaneously together. But to get that linkage in there, it kind of had to be a little bit bigger, a little bit bulkier. So we took it to Cabela's, took it to their buyers, and they looked at it and they said, "This is ugly, it will never sell." And as a designer, you're just like, "Oh, ow, that really hurts." But it was true, it was true. Like you put it on the shelf next to anything else, it didn't have that form that was going to help it sell. No one was ever going to pick it off the shelf to try out that functionality. Now I convinced the guy to go shoot it, and he said it's the greatest release he's ever shot. He wants one, but it'll still never sell. And so we had to table it and readdress form, because form was so important for the buyer that it had to look good, it had to look right. So that's why I say we really have to balance those as we ideate. You got to come up with something. So to fix the fatness of it, how do you elongate it, make it longer, look leaner, and help resolve some of those issues that they initially saw. But that's why, again, with ideating, we want to play with these and see how it all comes together. Prototyping. Prototyping is about one of my most favorite aspects of design. I love making things. It's what really got me into design. Prototyping and testing, because you're always going to run into problems you never saw coming. And so prototyping helps us understand where those are going to come from. So one of the great things that's really helped with prototyping is the advent of 3D printing, additive manufacturing, rapid prototyping. It has a lot of different names. But the nice thing is it can take complex designs and produce them for us. Whereas traditional methods, it would almost be impossible to make those. 3D printing's made it possible. And it's also helped us to then manufacture products as well, not only just to try to make the product, but to actually aid in the creation of those products. So to give you an idea, as you start to develop your own space here, what's great is injection molding. A lot of people will try to 3D print their part. The 3D print materials are limited, they're not quite as strong as the normal engineering polymers. But if I can just simply 3D print my injection mold, take it over to a benchtop injection molder, I can now shoot it in the nylons, the polypropylenes, polyurethanes, those types of things, and now I've got the actual part made in the actual plastic. And to a certain extent, I can even do short run production. So we could go ahead and make a whole bunch of them, see how it goes. So I was in camp, how do you say the story? Campa. They had a small shower head. This is an exact great part where you could do short run production, make a couple hundred of them, see how they sell. If there's great success or high demand for it, now we turn to traditional manufacturing. So you know it's worth that investment in the tooling because you're going to get those sales. Same thing with composites. You can actually make molds for your composites. So you want to make a new paddleboard blade, you want to make bike parts, things like that. You can actually mold them up and do your prototyping all from a 3D printed fixture or form. They even now have water soluble supports, so you can actually wrap and filament line handles, cross-section bars, things like that, all done in 3D prints. Sheet metal. You can actually form sheet metal parts with a 3D printer. I've done some of that as well. It's great there. Silicone molding. I know one of the projects I kind of looked at when I was here on Monday had some silicone parts. You could actually 3D print that mold, inject in your silicone plastic, and you've got the actual part. And now you can produce a whole bunch of them. And then this is one that I've done as well, is 3D printing a wax material. Do your investment cast. Now you've got it in metal. You've got a real engineered part that you can go test. And so kind of talking about just some examples that I've done. I'll start kind of over here just because it's one of my favorites. So brake levers right here. Like I said, I worked with mountain bikes, bike industry in Utah for a while. And so Aaron Gwynn, I know was a downhill mountain biker. Aaron Gwynn's a big downhiller. He was sponsored by TRP, so TRP was doing all of his brakes. And he hated the brake levers. He's like, I need new brake levers. They're not conducive to one finger pull. I need a redesign. And so we redesigned based on his recommendations. I 3D printed parts. You'd send them out to him. And he could test it somewhat, but you know, it's plastic. Those 3D prints, if you really played with them in here, you realize any kind of real stress, and boom, especially when that car pulls out in front of you, you slam on your plastic brakes, they snap and you go right into the car. So he was a little worried about trying it on a trail with plastic. So I went ahead and I investment cast them from those plastic prints, so the wax prints, put them on his bike. He was able to then ride and get real feedback. So we went through a few iterations that way. Well, it got to the point where he really liked the way they were feeling, so we were trying to get him into production. Couldn't get him to production fast enough, and the World Championship was coming up. And he called us up and he said, "Are these strong enough that I could ride them for the championship?" And I was like, "Well, hold on, let me go." So I went to the engineering department, put it in a fixture, test it, and like, yeah, it's got about 300 pounds before it'll snap, similar to the current ones on the market. He said, okay. He walked over to his mechanic. He said, "Don't switch the levers, leave them here." And he rode those. He won. So thankfully he won and they didn't break. Excuse me. But he was able to actually use that product to really try them out. And so therefore it landed on the final design, and then that's what went in production. But 3D printing, we can go ahead and use it to do mock-ups. So the ergonomic grips. And I've got some of the releases up here that you can kind of come see after the presentation. I'm trying to get ergonomics correct is a nightmare. Everyone's hand is different. So trying to get a generalized shape that will fit everyone's hand is very difficult. But 3D printing, in that prototyping, allowed me to design several handle sets. And I would mark with numbers so people didn't know, and they'd have to do blind tests and tell me what felt the most comfortable. And use statistics, so you can bring in the math department to run statistical analysis, things like that, to get those to fit right. Wakescape had a student who really wanted to make a wakescape. Boating in Utah is a lot colder than what you have here. I really like warm water here. And so he took the time and had the prototype out through several iterations and was able to finally land on his wakescape. And then another one in the bike industry, they were pushing for wireless derailleur systems. So they wanted, so there's no more cabling going through to save weight and to get the shifting correct. So I actually prototyped out a whole wireless derailleur system for cyclocross, 3D printing many components. This is one of the metal ones that we use, but on a 3D printed derailleur, I could ride the bike through the parking lot. I could check the gears, see how it would shift. Once I kind of started landing on the right design, then I would work with the engineering department, and we would produce them in metal, either through investment cast, water jet cutting, all those types of technologies that exist. And so it was a great way to be able to prototype that out and actually have it work. So you're riding down the road, clicking your buttons, and they just hope that no one used their Bluetooth on their phone and mess with you. That was one of the things, is you don't, what kind of interference does Bluetooth receive if you're riding on a bike and someone's on their phone? And we found out very quickly that the module we used got interfered with quite regularly. And so all of a sudden it started shifting, it would lock up. So we had to try different Bluetooth modules, different frequencies, those types of things. Because the last thing you want to be is in the middle of a race, and the rider next to you looks down, sees that you got it, and hit the jam button, and it jams up your bike, and then keep riding. So 3D printing, along with a lot of the other great traditional technologies that I've seen in your laboratory here, are great for producing these protos. You're able to produce and learn. Then everyone's favorite thing in the world is testing. So this is Utah State. That's our oldest building there, Old Main. And so it slopes down into town. So we got this really big hill on the side. So it's very popular for snow tubing and all that. Well, students tell me all the time during class, hey, I gotta go test. I'll be back later. And I said, well, all right. So they'll bring their snowboards or whatever it is that they've made, and they start snowboarding down the side of Old Main to test out bindings, boots, whatever it might be. And then they catch a ride back to the top, and they just do this endless loop during class time. And they have a lot of fun when they're testing. And so kind of that need for testing is we really want to know what it's capable of. A lot of the time, this is where engineering and designers team up, is how strong is it? How strong does it need to be? Is it going to do what we want it to do? Does it allow for multiple people to interact with the product? That's one of the big things, again, as designers, really human-centric. We want that experience. And so what I always tell people is if you want the same experience that I have when flying in an airplane, take a chair, jam it into the wall, and then try to sit in it. Because that's what it's like for me. I can't fit in those airplane seats. And so we want to make sure that it actually reacts the way we want it to. Because a lot of the time as well, we don't know if the consumer actually uses it the way we thought they would use it. And so just to that point, this right here is my little boy. So it's right about here that he probably stopped using the sled the way the designer thought he would use it. I don't think they intended kids to jump 4 feet in the air. 4 feet in the air with their sleds. So I don't know if you see it, there's actually a piece of the sled left after he hits the ground, because part of it shattered off. And so again, was it the right material for a sled? Was it thick enough to be a sled? Again, we need to test to understand what our kid's going to do with a sled. Growing up with 4 brothers, I can tell you, they'll never use it the way it's intended. It'll be going off the roof, it'll be going down the street, dragged behind the car, you never know. And so, testing becomes very important as we try to pursue what we want that product to do. So kind of as we push forward in design, generative design is becoming one of the big futures of design. And so the idea is we're allowing the computer AI to essentially help us design. Because when we look at this bike frame, there's no way you can perfectly design that as a designer. Yeah, you can get kind of the same look, but the other thing too is this has been perfectly engineered. The AI, you told it where all the stresses were going to be, so AI, or through the generative design process, the computer built all the rib sections to be exactly where they needed to be, exactly as big as they needed to be, and then you went through and said, yes, this is the one that I want. And so through this design methodology, this bike frame is significantly lighter, stronger, and just has this kind of cool look to it. And so as the designer, you can actually play with the aesthetics of this, but we're going to see a lot of generative design in the future. And so just kind of a glimpse of where design is going, we're going to start to see this. You might start seeing this in some of the play devices. You might see it in carabiners. This is where additive manufacturing and design are coming together, is in this concept of generative design. So in the architecture, you might start seeing trusses that look more like this than the traditional iso trusses, things like that. Because you know exactly where the load needs to go, it'll calculate where the strength needs to be and where that material actually has to go. And so when we take that approach with additive manufacturing, less is more. So the less that is in the product, the less time it takes to produce it through additive manufacturing, the less material is getting used, so it's a more sustainable approach. So one of the fun things, you can go down that road, there is a module for generative design. I saw somebody during the class using Fusion 360. Fusion 360 has a small module in there for generative design. But I just wanted to give kind of a look at what the future of design can become. So we've designed that product, you know, now what? Where do we go from there? And this is where, once we've completed it, we've tested it, we want to know how we're going to get it manufactured, how we're going to get it funded. Is it a viable product? You know, when and where will it get made? So as an example, this is a product one of my students designed as a small backpacker's camera. So the idea is that the lens can pop down and it just sits in a very small circular case. So that way it's a ultra-light camera for backpacking. And so he's like, well great, now what do I do? So he's currently trying to possibly pitch the idea to Canon and move forward with that. So kind of addressing that, we got to look at product viability. Is it a viable product? So I always use this example because it's something that can be drawn but never made. So a lot of the time as designers, what happens is we try to then analyze the product and we realize that $29.99 price point we were shooting for is actually $100, $200 because we made it impossible to make. We made it out of the wrong materials, things like that. So it produces a lot of design challenges, and so we want to make sure it's a viable product that can actually be manufactured. So as you're designing, you want to take that into account. Who are you going to have it made with? What are those materials? Where's it going from there? And then setting up your manufacturing. So that requires quite a bit. And this is where the more you do it, the better you get at it. This is where the outdoor industry has always struggled. Because typically products are designed by gearheads that love the gear, have a great idea, but they're not trained. They're not a trained designer, they're not a trained manufacturer, so they have to try to figure it out on their own. And it can take years for them to perfect that or really get going. And then this is where, as a trained product developer, or working with manufacturing engineering, we can identify the factory. Is that going to be a local? Is it going to be overseas? And so I always prefer to try to go local as much as I can. And overseas is a second option. Is it going to have sustainable practices? So the closer you are to your factory, or the more often that you see them, you can actually assess that. If you never go out and visit, you have no idea what they're doing. And it's just like leaving kids home alone. You know, you think that they are doing what's right, and then the police are on your doorstep, and you're like, oh, sorry, Dad. Went for a joyride in the car. And so those sustainable practices become very important, especially that outdoor industry. And so you want to make sure they're doing what's right. I had a fellow colleague, she was over in China, and she was walking through the factory, pointed out to a worker that they needed to stitch a different way, stitch this, then this. And later found out that that worker was punished because the American found a problem, and so it must have been her fault, not the way it was set up. And so the company she was working for went into the company and said, no, this is how it needs to be. And so they worked a lot stricter with that company about their sustainable practices and fair, treating their workers fairly. Sourcing materials can become a big one. You got to make sure that you got the materials from this textile mill or this metal factory, and it gets routed and sent on over. And that can become challenging. And then your last and biggest one, quality. Is this factory going to provide the quality I'm looking for? And again, that's where you need to constantly have those touch points. And the more, or the closer that factory is to you, the easier it is for you to get that quality where you want. It's easy to send bad quality to people you perceive, because then they're going to know that you're really face-to-face for it. But if you got someone coming in consistently and addressing the quality, it helps bring it up. And so those are some of the major steps that go into setting up that manufacturing. That's one of the nice things about here in Puerto Rico, we already have textile manufacturing. Where we are in Utah, there's very little. Nothing on the scale of what is done here in Puerto Rico. So everything is really outsourced. And so they have to constantly go to China, to Vietnam, to Indonesia. The workers hate it because they'll spend 3 weeks at a time away from their family, away from their home, assessing products. But if you can have them manufactured in your own backyard, it's just a day trip. It's something that you can address. If there's a problem, it's very quick to get to and get back. And so creating more of that true circular economy to where the manufacturing is close, it's less fuel, it's less CO2 output, you can address those kinds of issues right then and there. Some of the funding, right? So you got this great product, you figured out kind of where it needs to get manufactured, now you need some money. So there's been the traditional, let's start off in the garage and let's get going. So Steve Jobs, Apple Computers out of a garage, IBM out of a garage, a lot of those great ones. If you can kind of start off slow and self-funded, garage is a great route. The advent of the internet, Kickstarter, right? Kickstarter has become a great way to launch products because one, it helps you immediately get the funds that you need, and then you can set up your manufacturing, get your products going, and hopefully make a little bit of money and then start the next order and get going and fund your Kickstarter. Bank loans, investors are another great way to get funding up and running. And then the last one, just because I know we have some students in here, competitions are actually a great way to get products up and going. We have a competition at Utah State as part of our entrepreneurial center. One of our students entered in what we call the origami backpack. It's a fold-out blanket that then folds through origami into a backpack. So you can take it to concerts, to the beach, picnics, things like that. She entered the contest. She won $1,000, and so they're using that money to then start up Kickstarter and get funded to then take the product to market. Another one that I've got up here, and like I said, you can kind of come take a look at some of these products, is a clipless bike pedal by one of my students, Jake Van Wagner. And so he got tired of riding his mountain bike with clipless pedals to school. He said it would be great if there was just something he could click in so he didn't have to wear his normal footless shoes and then change his shoes. So he designed and developed a pedal that he can click in, and then he just gets to school, pops them out, puts them in his bag, a lot less space in the shoes, great little product. And so he's in that process of looking at trying to launch something either through Kickstarter or other competitions. And so other competitions we have just in the state of Utah that's open to every college student is outdoor products. And so people enter those pitches. You can win up to $50,000, I think was last year's prize, to get your business up and going. Because that's what they want. They understand that the economy, whether it's in Utah, whether it's back east, whether it's in Puerto Rico, is important. And so having those outdoor products get made help boost that outdoor industry. And so competitions are a great way to get those products up and going. So as we move from manufacturing into product use, it's really about educating the consumer. And so we want to make sure they understand the impact of their products and their product choices that they're constantly using. Because if they understand how to care for their products, they can extend the life of that product. So whether that's waxing your boards, waxing your skis, helps extend the life. If it's repairing the hole in your bag rather than throwing it out and getting a new bag, it extends the life. Right before I hopped on the plane, I noticed my side bag that I've carried for about 8 years now, which my wife will attest to, and it's getting gross and old. But had a big old hole in the bottom. I'm like, I got it. So I threw my daughter off the sewing machine, jumped on, sewed the hole closed. Like, yep, that's good. On to the plane we go. And so extended that life of that bag. But if they understand how to do that, it's a great way to extend those lives of the products and help those products move forward. And so as we educate the user, it'll help them understand that story, help them understand why it's important that they buy the product that they're buying. And so if we don't tell the story the right way, the user's never going to accept what it is that they're doing. And so a lot of the time, price is king, is what they'll say, right? So everyone walks up, they look for that cheapest price tag. Here we go, that's the one for me. Because they don't know different. The only thing they know is this one costs more, this one costs less. And so we look at product design, we have to help them understand. We have to help them understand why they need to pay the higher price. We need to help them understand what the difference is between the two. And so, as we move forward, how much separate? again, a powerful message, right? So this is what we're really trying to strive for with our user. So if you understood that each one of those plastic bottles you drink from would actually turn into something, something new, something beautiful, you'd be more apt to recycle. And so I have to harp my students all the time. I walk by the trash can and I'm pulling out aluminum can, plastic bottles, putting them in the recycle, trying to help educate that consumer about the product. So bottles need to be recycled. But again, if you had the choice between buying fully synthetic, oil-produced jacket, where you have the option to produce or choose a recycled plastic bottle jacket, you know, maybe it costs a little more, but are you willing to make that difference because it's a sustainable, or at least a recycled, reused product that became new again? And so there's a lot that we can do as we educate the user as to how or why they might need to make those choices. And so as we roll into that, another big impact that we need to educate the consumer about is the end of life. What are we supposed to do with it when we're done? This becomes a huge, huge problem. Because a lot of people don't know what to do with random products when they're done. I try to help students in the woods lab. They take old nails or the nails that they bend. As you're sitting there in the woods, you're trying to hammer that nail straight, and no one can do it. I swear it's an impossible feat to get a nail in straight. But you get all those bent ones, and most people throw them right in the trash. But if they have that can from lunch, they'll throw it in the recycle. Both made from the same thing. They're in two different forms. And so because in one form they associate it with recyclable, in another form they think garbage. Even though both can just as easily be thrown in the recycle. So we've got to decide what are those end-of-life products. And so one of the this is a REI article, one of the most promising trends in product development is the recycle of outdoor gear. So these glasses right here, all the frames came from old fishing nets. So they take those nylon fishing nets, they shred them down, put them into pellets, injection mold them, we've got sunglasses. This climbing rope up here is actually recycled climbing rope. So using a similar technique as we saw with bottles, they can actually respin and make new climbing rope from mold. This right here is some bags that are produced from other bags that are either worn out, and so they can take different pieces from them. But the idea is to take and determine what is the end of life, what are we going to do with it? Is there a way to do a return policy as a company? And so I can take that and refurbish it. A lot of automotive parts are done that way. Their starters, things like that, they just reuse the housing, the new guts inside, and resell it. Same thing in the outdoor industry. Is there a way to reuse those tent poles? Is there a way to reuse the fabrics? If not, can I turn them into something new? Is there a way to allow that to become a new product? And so end of life has really got sustainability at its heart. We want to be more sustainable. And so there's certain products that I just personally now feel like we should never use new materials to make. Small bags, things like that, offcuts from textile mills would suffice to make all of those. And so we've made that major push to produce repair programs. Patagonia has been a great brand to push the idea of worn wear, where you can send it in, they'll repair it. It's even changed the way they design their clothes to make them more repairable. So zippers, for instance, are typically a pain in the neck, especially if they're down, and you pull the zipper off, and all the down starts shooting out at you. And if you've ever played with down, it goes right up your nose. It's just awful. Well, they said, well, what if we just run 2 more stitches down the side and seal it down from the zipper? They said, well, it's going to cost a nickel more. And they said, that's something we're willing to do. And so they ran 2 extra stitches down, so now they can take the zippers on and off without down escape. Just a simple stitch, that nickel difference, but as a company, as a brand, they said, this is worth it. This is worth it because it makes it more repairable, makes it easier for our workers, and we can keep that piece of clothing going much longer in its life. Renewal's another great brand. They're out of Oregon, does the same thing. They work with a lot of brands to try to repair. Now we do hit that point where repair doesn't work. So waders is an example. for those that fish. You get enough holes in your waders, and it's okay, it's time to retire. What could they be turned into? Well, I had a student who had some Patagonia, destroyed waders, too many holes, and so he decided, well, I need kind of a waterproof bag. So waders are obviously a good choice of material because they're waterproof. They already have a waterproof zipper in them. And so he decided to make his own tackle bag out of old waders. And so it became popular. He did this one, and another student worked with Orvis, like that brand. They started sending more. They're like, this is great. We got to get more of these made because we need to do something with waders aside from put them in the landfill. And so we've got those upcycled products that become a great new market opportunity for you. I had students who do jean chalk bags. They go to the thrift stores and they find the jeans that are just too trash. And they remove certain sections, make chalk bags because they already have a pocket in them. So as a student, you can slide your ID in, your key in, and then you can go apply them in the gym or apply them on the boards, whatever it may be. So it creates another new market that a designer can design into and moving forward. And then our refurbishment program is the ability to refurbish all those products and hopefully give them a new life by bringing them back in, replacing the parts that are worn out, and sending them back out. It's a great new opportunity for designers, engineers, business, students to all come together. So a lot of these programs we're now piloting at Utah State. We found what's been really hard is people don't know how to sew anymore. It's kind of a lost art. Grandma knows how to sew, but we don't know how to sew. I don't know how to sew. My wife taught me a little bit of sewing, enough to fix my bag, basically. But the idea is it was lost, and so these repair companies are like, we can't even hire people. There's no skills. People don't have the skills, and so as we've been teaching at Utah State, we've had a lot of brands come in, and we've set up repair programs with them now. So certain brands will bring us their weekly shipment of returns that are, threads are coming in done, zippers broke. We repair the products and send it out. So our student clubs are able to fund themselves that way because they can go to trade shows, conferences, things like that. It's been a great opportunity. They've also been able to upcycle products. So there's certain returns that companies get they can't do anything with, liability issues. So they take those products and turn them into non-liable issue products. Dog leashes, things like that. Just to create another opportunity for our students to gain that experience and learn the logistics of getting product brought in, getting it sent back out, and all those things. And just allows them to constantly think of new products that they can produce out of these worn out or old products. And so when we think of that end of life, what will you make? So these are just the first prototype chalk bags that we made. This is an old tent up here turned into a bag. So it's just a great opportunity. So this is the one that, like I said, we're doing at the trade show. Everyone gets those nice lanyards from every trade show you've ever been to. What do you tend to do with your lanyard when you're done? Into the trash they go. So the idea is that students are sewing up a couple hundred of these, and we'll be sewing them at the show. The idea is they produce them, you bring them to your lanyard at the end of the show, and they'll actually sew it in as a trim piece or as a draw cord for the bag. And so then they'll take the metal pieces, recycle those, and then your lanyard went into something new instead of just into the landfill. And so, again, that's the big push that we like to make with end of life is what are you going to make? Where's it going to go? How does it fit into that circular economy? And that's just the great part about taking programs and meshing them together with so many other programs. Because they can really strengthen each other, we can learn from each other. And so it's just been a great opportunity to see some of that occur in here as well. So kind of just in summary, as we finish up, think about the impact of your design. That's really what we're looking for. Is that design going to be something that leaves a huge footprint on the planet? It's going to be something that leaves a small footprint? Or is it going to reverse the footprint? Manufacture it in the right way, not the convenient way. That's one of the biggest problems we have, is people seek that convenience. And so they don't care what they destroy in the meantime to get what they want. And so it's a lot more work, but you want to make sure that you always are doing it in the stick to your integrity, stick to your ethics, and do it the way that it should be done. Educate your customer. If you don't educate the customer, they're not going to know what to do with your product when they're done. They're not going to understand why they should buy your product over another. So you got to tell that story. You got to educate them. So as a designer, tell that story. And then last, begin now to think about where that product's going to go, where it's going to end up. Landfills are gross. Part of my PhD, I had to do some landfill gas reclaim, like methane gas from landfills. Anyway, I was talking to the guy who does core samples. So just like we core ice, we core sand to check geologic time. They do the same thing in the landfills. They will core it, pull it out. He says the grossest thing is when he hits like the 1970s, 1960s, and there's still perfectly preserved hot dogs in the landfill that haven't broken down because it's airtight and it's like it's been vacuum sealed forever. He's like, the less we put in there, the better off we're going to be. So let's think about where we're going to put it. So as you're designing right up front, think about some of that research of not only what's it going to be made out of to make it more sustainable, but where's it going to end up when you're done. So when you do discard it, is it recyclable? Is it reusable? What is it? So help that consumer understand and help progress the circular economy is really where we want to see a lot of the design go. And so thank you for listening. That's kind of what I want to share today with the outdoor industry and design.
Any questions? Vamos, atrévanse.
I was really interested in the recycling aspect. So we have a problem with trash and recycling Puerto Rico. Like, we have no more landfills; they're already filling up. Because of EPA regulations, the landfills is really pretty hard. Yet the recycling industry has been really hard to take off. And even with some foreign, outside capital that's been trying to invest in, basically recyclers have resorted to try to sell the recyclable to other markets and ship it out.
Yeah.
Which has now become another problem because of tariffs and recent regulation changes, right?
Yeah.
So how do you envision that the design industry can help create the market for potentially creating industry, basically?
Yeah.
Because we mentioned we have a textile industry, but getting plastic bottles to become textiles that requires kind of different industries.
So a lot of it is again, the consumer drives the market, right? And so what the consumer wants is what we tend to fall behind. And so if we can educate the consumer on the need for recycled products, the idea is if we can get them to buy into producing or wanting recycled nylon for swimwear, recycled polyester for swimwear, as those types of things become more popular of a choice, the more the market tends to follow. And so if there's that demand for it, then the industry tends to follow by saying, okay, we'll start to produce it. But yeah, it does require the driving in of your own recycling center, like here in Puerto Rico, right? To start gathering the bottles, producing your own shreds, recycling it into usable materials, plastic pellets, things like that. And so you have to kind of drive it and look at it as a method of push on the government side and a push on the industry side. Because it could be that you just recycle the bottles here, you do your own shred and make the plastic pellets for injection molding, but then that's the product that gets outsourced. Because maybe you don't have the infrastructure or there's not that investment for making the whole textile mill to weave and make that actual fabric. But maybe the plastic pellets is as far as you can get here. with the minimal investment maybe. But it's trying to help them understand the need for recycled product, and then pushing other industries as well to want more recycled product rather than just virgin product. So when I worked with investment castings in Oregon, we would use about 75% revert, which is just recycled metal from the casting process mixed with virgin, and that worked great for our products. So we didn't have to keep buying virgin materials and then exporting the recycled. And so there's just different initiatives, different programs maybe that really need to be pushed on. But that is because, as you said, you fill the landfill, what are you going to do? And so maybe that needs to be addressed in some of the legislation here in Puerto Rico to address the trash issue and push for more of a recyclable center that produces product rather than just exports. So when it comes to ergonomics, some of the greatest people you can talk to are physical therapists. A lot of the time they understand the structure that the back needs to be into, as an example, the seat. And they'll tell you what kind of the posture needs to be, they can give you measurements, things like that. But just talking to those different occupations that exist in that realm you're looking at, you might even talk to a furniture designer who designs chairs. Say, hey, what makes a comfortable chair? Or how do you account for different heights when you design a chair? So looking at a kind of an interdisciplinary approach to design is what always helps. So one of the things that I did with hands is I would take clay and cover a wood rod with a string on it, and I would have people put it in their hand with a string between their fingers, similar to release, and pull on it, and it would mash the clay, and then I could actually measure those radiuses out of the handle and then apply them to design. And so, but again, it's really understanding who do I need to talk to, how's this person, because then again, a physical therapist might not be trying to sit in a chair and pound. So they may have never thought of that. So you might talk to some kayakers and say, hey, what about this? What's that motion? And studying that motion, watching video, and seeing where the chair might actually have to go.
So I want to ask another, this is more like a technical question, and it's more school related. So with rapid prototyping, there's different ways of 3D printing nowadays. There's resins, and then there's a filament, and there's a few of them. And I mean, I've used the filament type, Prusa type printers, and they're very limited in scope. How much diversity do you really need to at least start, with the prototyping process? And for a school like ours, in terms of investment, right? In getting 5 MakerBots, or getting one really interesting $50,000 resin printer. Right?
And so that's the thing, right? From an educational standpoint, it's usually easy to get money one time than it is to get ongoing money in education. And so what I've found is the FDM printers, the MakerBots, are great learning tools at the beginning because they help you with form, they help you do those things, but it can be limited in what you can really do. One of the other ones I really love is the Form Labs resin printer. They just came out with Forms Lab 3, which has the bigger print envelope, so I'm like, yes, it's fine. But it has those different material properties that you can get out of it. So with an FDM, I can epoxy coat it, sand it, get a really good looking form model. But if I want to take it to that next level, the SLA printer, the Form Lab, will give me that high temp material that I can injection mold into. It'll give me the ability to make wax to do investment casting with. It'll give me the ability to do some of the flexible materials. It'll give you that high resolution finish down to the 25 micron, 10 micron, something like that resolution. And so I prefer those that are more sustainable from an education standpoint, because we have a couple in the engineering department that are the $60,000 object Onyx printers. We can't ever use them because they're too expensive. It's just like, well, it'd be great to print this project on there, but it's going to cost $200. I don't have the money to spend $200 on just your print. You can do it, and the students are like, $200, you're right. I'm buying a ski pass. So that's why I like just having enough capability in that lower market of 3D printer to be able to do most of the things that I think a student would want to work on. So that's why I say with the forms, I can do the injection molding, I can do the investment casting, I can do some high-end prints. FDM, super cheap, and I can just let them print to their heart's content, just so they learn it and understand it, and play with that form. And there's some crazy things that you can start to do with them as well, and they're getting new filaments all the time. That's where I see the best bang for your buck, is in those FDM printers, and then like one SLA machine to do more final design or more manufacturing type aids. Because you can pick up just like a hand injection molder for about $1,500. And so then you can start shooting real polymers in there. Have a lot of fun with it. Any others? Alright, if there's no other questions, I've got just some examples. You want to see those arch releases of those pedals sitting up there. You can see kind of the 3D print, the rough machine one, and the final anodized one as well. But kind of just turn it loose to that.
Andrew, thank you. Gracias a todos por asistir. Esto pues, son parte de los comienzos de la Asociación de Diseño de Productos. Estará conversando brevemente. Andrew, así que Andrew va a estar trabajando con nosotros en diferentes colaboraciones para que sus estudiantes puedan nutrirse también de la experiencia del diseño de nosotros, de la manufactura local y viceversa. Así que le agradezco a todos los estudiantes que vinieron, los colegas, gracias muchachos. Y tenemos una reunión ahora en unos 3 minutos, así que nosotros nos marchamos con Andrew. Gracias a todos, a Roy, a que vinieron, a todos el apoyo que han dado, sobre todo los estudiantes. Thank you, Andrew.